Okay, so that was Privet Edge Detector. Sobel Edge Detector, exactly the same set of steps. You have image, you perform smoothing, that will give a blurred image, derivative in X. Same for Y. The only difference is the filter which you're using to perform smoothing. The Privet Edge Detector actually uses a box filter where all the values are 1, which means that it's actually giving equal weightage to all the neighborhood pixels. In this case, we are actually giving more weightage to the current location. All right. And the derivative mask, it remains the same. And again, if you use, if you try to combine these two, you will get this filter, which again, you can just use a one single step to perform Sobel edge filtering. Same is true for bidirection. Okay, so it's the same derivative filter, but the smoothing operation is slightly different. Instead of having all ones, instead of having box filter, we have this kind of weighted filter here, which is giving more weightage to the current location. Okay, so that was Sobel edge detector. Now let's try to cover the rest of the steps, how you can actually determine whether it's an edge or not. So it's pretty straightforward. You have the input image. You have these filters. You don't have to perform them all those steps separately. So just apply this. You will get like derivative in X direction. And this is going to give you derivative in Y direction, which means to say like edges in X and edges in Y direction. Then you can compute the magnitude of those edges. All right, you know that if you have to compute derivative in an image, we just revised today like how you can compute the magnitude. So you just square the values and take the square root. So you will do this for all the pixel locations. And then you will have to set some threshold, which will say that, okay, if the magnitude of the gradient is greater than this value, it's an edge. If the magnitude is lower than this value, it's not an edge. So it's basically just a thresholding, and you'll have to do this manually. There are ways to automate this process, which we will talk about, I think, later in one of the later lectures. But right now, I mean, just assume that you have to set this manually, and that's going to give you edges. Now, let's look at like a simple example here. Let's say if this is your input image, if you compute your derivatives in X direction, that's the output. If you compute derivatives in Y direction, you will get something like this. And then you can compute magnitude, which means to say for each pixel, you will actually square the value in corresponding these maps, take the square root, and that's going to give you just one single map. Okay, so that's the step. And once you have this, then you can see that like some of the pixel values are actually pretty high and some are pretty low, and most of these are black. So the dark pixels are actually background, which means that there is no edge. The brighter pixels are saying there was definitely an edge. And then in between we have this like the gray region, which is kind of, it could be an edge, it couldn't be an edge. So that's where the threshold play a very important role. And depending upon what threshold you use, your edge detection result will differ. For example, if I say the threshold is 100, and this threshold is on these activations here, so you will get something like this, which is showing you the edges which are being determined by this algorithms. Okay. Now, how this threshold will change the output? If you lower the threshold, then you will actually get more edges. And if you increase the threshold, the number of edges which are detected will be slightly lower. Now, we have seen this plot earlier. This is the way, like one of the ways to evaluate the performance of your edge detection algorithm. And this green dot over here, it's human performance on this data set. And if you look at this, like the Sobel and Privet, I think we briefly covered this in the last lecture as well. So they are almost at the same time, 68 and 70. But the performance is almost similar, 0.48 and 0.48.